few minutes.
Yeah. So, great. So, welcome to the community meetup. I think what we were saying, a few weeks ago, there was the sort of swung rendezvous looking at interactive plots and stuff. And I think, Lindsay, you suggested that it'd be a good idea to maybe go and revisit that. And I've got some examples of that. I've pulled together some examples of the plots that were demoed there. And those plots sort of use Bokeh and a little bit of Bokeh trickery in order to keep the plot embedded and live. And for example, I'll share this Curvenote afterwards, and there's a few plots that like Dieter put together. So there are cases where you can nicely and compactly define a function that you can then, vary a parameter on and have the graph update. You've seen this one before, I think, have you?
Yeah. Does it save all of the data in between? Like, so when you're moving that, like it's indexing into an array of stuff that's stored.
No, this one isn't. So if I go and look at Dieter's toy project, he's actually used a JavaScript function, I believe, and embedded that at real time, I think. But let's see, because we'll be using a few different techniques. So I think this plot's the same principle. So he's got this this plot, which is resistivity with offset, and he configures a data source, which is a column source, and has this. Yes, so he has computed. In this case, he's computed a whole bunch of things on the slider value.
And then it's just interpolating between them.
I think it's not even doing that. I think it's, well, maybe it is interpolating between them, but it's basically, look, here's his callback. His callback is just selecting a value out of the dictionary.
It sounds like Wesley's in the waiting room, Steve.
Oh. Keep an eye on all the Zoom windows. Yeah. Yeah. So in this one, I believe he is. So is he? So pre-compute the data, yes, and store the output of each resistivity in the dict, with the resistivity as a key as a string. And then he's doing that for that entire X array. And then all his callback is doing is picking the data out of the dict.
Cool.
So if you've got a lot of data, or if you have a lot of dimensions you want to model, then that's it. Gets to a pretty big parameter space, I guess. And that was, I guess, the drawback of that one.
Yeah, I'd imagine that that's pretty good for some of the educational use cases of that, like Lindsay and Liz are working on. Yeah,
being able to construct widgets to show particular functions and stuff. And that was sort of the first pass that we looked at. And then Wesley started playing a bit more with panel. Don't know if Wesley's fully pulled in. But then on the panel, what he was able to do is he was able to, there he is, build the whole panel plot and then call embed function. And then what the embed function did is go and gather all the permutations of your data and pack it all into the plot, I believe. So if your slider was out slicing an array in a particular way, it would embed the plot with enough data to be able to do that. That's right, Wesley?
Yeah, when you hit the embeds, you hit the number of options. So it calculates the different time steps and the maximum amount of ones it wants to take. So if you've got a continuous variable, obviously that doesn't work. I was coming across problems the other day if you're writing like there's some differences with how it works with pure JavaScript and callbacks and stuff with custom Python in it. And the custom Python, sometimes I was having problems. I don't know. There's some funky stuff going on. It's not fully, yeah, it's not like full production yet, but it's getting there.
Yeah. But the trick was, I believe, in order to get it to work, was just waiting on things rendering. This critical embed call at the end here. So the use of interact is what's letting you build the panel in the first place. So the code's pretty compact. It's loading the data set into Xarray and then defining the plot function, which is calling a hollow views plot as an image plot, and then passing that into interact with the variables. And Wesley was saying that works out that you need these sets of controls based on the nature of the variables. And then embed figures out what you actually need to pull into the state. But on some of Wesley's examples, that was then getting into the megabytes, no?
Yeah, I think we're
Of notebook size. So there was a lot of state getting packed into the notebook. And I think the biggest one was around 20 meg that you managed to,
get in. I think we got somewhere around 40, 50 if we want to standalone.
Yeah, which takes time to load, but it does go in, I think. So that was one side. Did you have another question there? Were you about to?
I'm just trying to think of like what examples are fitting from some of the geophysics like education stuff, because there's some that are just like simply too big. We would easily generate several megabytes, but there's some like there's a little DC pseudo section apps and things like that that we made with matplotlib, but it wouldn't be hard to translate that over, and that is just like it's an example that would be just as simple as this.
Cool. This is back to the JavaScript now. And I just extended the JavaScript a bit to start putting multiple controls on. Because in the JavaScript, you've got to be able to write your function in JavaScript rather than in Python is the drawback. But then once you do, you can easily add many more parameters without having any bloat at all. So this is really lightweight. But you're in the situation where you've got a code in JavaScript there. Interesting thing about Jupyter and as well Curvenote is, for example, the error function isn't defined in JavaScript maths. And there's actually funky problems with JavaScript's power function as well, I found, for fractional powers. It doesn't work. And so in cases like that, what I've done is used the IPython display for JavaScript, and you can use that to sort of shunt a library on page. And then Curvenote will also load that for you. So now this is using the math.js library instead of the inbuilt JavaScript in order to calculate the plot. Which is interesting because there's none.js, and then there's a couple of JS libraries, approximating some of the stuff we're used to in Python. So you could go that way as well. Again, for defining compact functions and stuff.
And this works in the Jupyter notebook as well, yeah?
Yes, it does.
That's cool.
Cool.
What was it? Oh, sorry. I was just going to ask if it would be possible to hook up the like widget controls that are on the Curvenote dev. Like, can those wires be connected? Because that would be pretty cool to be able to actually connect like text to a plot.
I think we can. I mean, not right now, this week, next week. But I think we could figure out how to do that.
Tomorrow, Steve, come on.
That's the whole point. It would be lovely just to be able to bring the plots in and then link that back into the text the way that the the way that the Curvenote dev components do it. I think that's a great aim.
Yeah, because then you're actually writing directly in line in the text, and then basically, well, the amount of people that can do that is much wider than maybe the people who can write both in Python and JavaScript. So then you can start sharing these things, which is totally cool.
So definitely. So on those lines and stuff, I shared this in the Share It channel the other day because tomorrow there's a rendezvous on geothermal, and Alex sort of put this out there. And this is the IEA, which is, I think it's the European Renewables Organization. And they publish a lot of things, a lot of reports on their website about all sorts of technologies and, fuels and analysis across different industries. And they publish things like this, which are just lovely, well-formatted online publications, technical publications. And they have lots of graphs and charts in them. And they're not big interactive things like we've been looking at in the last two, but they just add just a little bit of interactivity that it's just enough to bring the thing to life, because it's just enough to start going in and querying, just like having hover effects. So you can actually interact with them just a little bit, transforms the article, And I think this is exactly, in order to do this, they have their own web team building out their own platform. I viewed source and had a good poke around in there looking for the name of some framework or something, but I couldn't find anything. So very likely this is custom built. So an organization like this can have the budget to do that, but I think the idea of a Curvenote is everybody should just be able to go and do that type of thing and include this type, make this type of article with even a little bit interactivity to be able to just bring things to life. And these things you can open as full pages, and you get sort of a related charts thing. So this is a lot of what we're aiming for with Curvenote, being able to give you a way to do that easily. And then that's why I'm super excited today to start to get into Altair, because I've known about this library called Altair for a while, because there's this thing out on the web called Vega. And what Vega is some set of very clever people sat down and figured out what the grammar of graphics would be. So if we were going to describe all of the plots as a language system, what would that be like? And then that arrived at the sort of Vega standard, which I'm not sure is even completely implemented anywhere fully yet. I'm not sure. But in JavaScript, they built this thing called Vega Lite, which is a much more compact library. I think maybe that's it. Vega does exist, but it's massive. And so Vega Lite is the most common subset. And then somebody built a Python wrapper around it called Altair, which allows you to do all these lovely, lovely plots. And what I did was, the docs are amazing. And I think the docs are amazing because with Altair, it's amazing at embedding its state. So by default, it embeds everything directly in there. You get these little menus in here by default. And the things are interactive. They've got the selections on. And I don't know, for me, like joint selections, you can do cross filtering and all sorts quite easily. I mean, that is the code in order to do that. Where you say chart 1, chart 2, and I'll OR them in order to get a plot like that.
Oh, and you OR them. Oh my gosh.
So it's a very object-based system. You can create an object and give it to both charts, and then that object becomes the link between the two. So they've taken this Vega thing, which is when you work with it in JavaScript, you can create a whole visualization just by writing JSON or YAML in a declarative way, and then you get an interactive plot at the end. They've managed to turn that into this sort of, I don't know, you'd say a fluent API with lots of chaining. It seems a little bit D3 in that you start off and the first thing you do is you give it your data, and then you sort of give it a rendering chain of what to do with it. which is pretty nice and compact. And they managed to do that without all the filtering controls by the side that sort of Bokeh gives you, which is a bit cluttered sometimes, no? And so I think this lets you design more compact plots and really do things with selections, which is single selections. Yeah, I can go around selecting things in here now. And now I can multi-select, I believe. I'm not done here. Which is amazing. And then this example I shared on Swan, which is the same thing. And now again, they've created two plots and they've ordered them in order to use one as a legend that then drives the selections on the other ones from that piece of code, which is amazing. And these things stay live, and they also stay live in Curvenote. So you can be in the notebook. It's slow to load for me. You can be in the notebook, and I sort of set up Jupyter, pull down their tutorials off GitHub, and just save them all. This is always slow when I'm on Zoom. It's always fast when nobody else is looking. But these things all render and stay interactive and in a beautifully lightweight way. So I think this is really worth exploring a lot more. And things like this, these all become linked. We've now got 4 linked and linked brushing. So I can come in here and you can start doing cross filtering across your data set. So really quickly, you're already in sort of data science mode now. You can start segmenting out things and see how that, if that pulls out clusters in completely different dimensions. Yeah, so I was really clicking around to find out more. I was really happy to see that today. And I think somebody called Soup, who's a user on the community channel, he actually pointed this out the other day that he'd been trying some. I think he's an Altair user, but I've not seen many people in our geospace use this at all.
Lindsay, have you seen anyone who's used Altair or Vega all that much, or?
Not in the geophysics space. I mean, I've definitely come across this sort of in the broader Jupyter space. I think like some of the core contributors to the Jupyter project are also core contributors on Altair, and I think even Vega Lite. No, but I've hardly played around with it even myself. There's so much like in terms of the interactive or sort of the JavaScript plotting, like I certainly haven't formed my own opinions yet on sort of Bokeh, Plotly, Altair, and what are my go-tos yet.
Yeah, I definitely like the interface better than like Bokeh or Plotly. Just like it's cleaner.
Yeah.
The SVG plots.
It is. I mean, out of the box, they've just managed to make it. They've got this just compact enough. The spacing's right, and these are beautiful. I mean, and I haven't looked at the docs yet. There's hover selections, and then there's ways to get this data out into other plots by linking them.
Yeah, this is fantastic.
Yeah.
Yeah, definitely worth spending some more time on. I think I want to play with this quite a bit.
Have you seen things like stream plots? That's always one that it's one we make so much use of in Matplotlib with showing the physics of stuff, like showing currents and things like that. But I find it's not quite as common.
Is that like a quiver plot, like arrows?
It's a bit different. Stream plots are like, I mean, same idea. Usually a quiver plot, they're like disconnected. Stream plots would often connect them.
There seems to be.
Well, who knows what they mean by stream?
Yeah.
I feel like that requires you integrating across the field, and
Yeah.
so I'm not entirely sure if that's would be in the JavaScript side of things, but maybe.
No. What is very interesting in here though is there seems to be some level of aggregation, etc., in here. When you pump the data in, let me get this one open. Let's see which one I saw it on.
No, the stream graph is, I think, not the same.
Not the same one.
It's a stacked area graph is what they're referring to as a stream graph.
Okay. But look at this. This is, so here we're pushing our data in cars. We're saying our mark is a bar. And then you're starting to set up the plot. We're saying axis Y is the origin of my data frame. But X then is an aggregate of the count of the different categories. So it's actually doing some aggregation that you might otherwise do in pandas, no, at the plot time, which is interesting.
Yeah, I remember, Lindsay, you talking about how this is like a total flip on your mental model of how you construct plots of like, because this is very much a data first driven model rather than a visualization first driven model, which is, well, anyways, that's different.
Yeah. HoloView used it pretty similarly. And yeah, that took me like a while to get my head wrapped around because I'm so used to the Matplotlib API. It flips it on its head. I like it, but it, it definitely is an adjustment.
Yeah. It reminds me a little bit of this as well. I don't know, processing. It was the same sort of thing. P5JS.
Oh, P5, yeah.
Where you specify the data and then you specify the rendering actions as a chain on that, like almost like a render tree.
I've got to run, but have fun.
Yeah. This allows you to do, what's this? And that allows you to do crazy things for visualization in here. And it's pink. Cool.
Very cool.
That was great. Yeah.
Wesley, have you played with Altair at all?
I haven't touched Altair. I've generally these days just been using HoloViews because it makes plotting quicker, and that's what I need, rather than playing around too much with doing cross-plotting. Yeah, no, I haven't played with too much recently. I was just trying to go see if I can get a VTK.js to pop up inside a cell, which we could try pushing to Curvenote with pure JavaScript, but it doesn't seem to be working too well.
Yeah. It's working in the Jupyter?
No, it's not working in Jupyter. So that's the hard part. Anyway.
Cool.
No, I haven't really tried any of these fancy other stuff.
Yeah, I'm now at the stage where I need to sit down and really read the docs in order to understand how to play around with this. But it looks great. And I mean, they're building the docs for Sphinx. And of course, their stuff's going to work amazing in Sphinx because it's immediately embeddable. I think in the tutorial, Wesley, one of the first things that actually shows in here is how to get the HTML up. So for any chart that you manage to build, they're building these little things. You can just do, I'll chart list the docs. Yeah.
Save
you can just save it straight up.
The API looks a lot like the Plotly's API, doesn't it? From like what I'm saying. Well, not the old Plotly API, the nice one, not the new.
The Express.
No, not that one. That's the crappy new one. The old one.
Okay. The old one.
the old one where you call graph objects or something like that, and you just
Yeah.
construct everything as a JSON, not JSON. You just construct everything as a dictionary. And then they went and did that plotly express, which kind of just really annoyed me. But the old one was good.
But I think they're trying to do the same thing as what's happened with pyviz, no, where they're trying to really abbreviate it, so there's just less.
But it's kind of so they try to abbreviate things. But the nice thing with the HoloView stuff is that you can change your backend to, rather than everything being inside Bokeh, you can just say like, okay, I want this to be in Matplotlib, or okay, I want this to be in Plotly. So it's just like a generic plotting library in the end, and it's not necessarily specific to to Bokeh or Plotly, which is why I use that most of the time. But yeah, you can, with Plotly, the old one, you could write a lot of custom JavaScripty stuff. Well, the layout was the layout was more of a declarative, what you want to see, rather than, I don't know.
Yeah.
You got to dig out the old docs.
I think this is some of it, where you'd have a figure and you say go figure, graph object figure. Figure, add trace.
Yeah, that's more of the style. But you could actually still write it as pure dictionaries. I think you could actually write like fig.show, and you just have it as a dictionary saying figure. Right. And then it's got data and layout, and like all the figure, when you write it like that, all it's actually doing is just creating a dictionary under the hood, which is just getting passed around, which was nice. But which was understandable to quickly, like you could really understand the library quickly and change around, and it was pretty transposable.
Cool. Another thing I love is Facets. This is multi-charts. This is lovely. And this was the one that we saw. And that's just by adding rows and columns. Cool. I think this is really good when you are like, when you actually you want to get it plot off quickly and let people do exploratory stuff on top of it without having to reach back to the code. Cool. Great. Anyway, that's all I had to show. I will share this tutorial project and for folks, and keep learning, hit the docs, and try and build something out on some different data. Cool.
Oh, thanks for sharing, Steve. It's always good to dig into these things.
Yeah.
It's easier than doing it all yourself, trying to work out what's the best library to go and plot with.
Yeah. Has anybody else been up to anything else? Anybody got anything else to share? Burning questions, things that have gone wrong, things that have broken, things that worked this week? No.
One other set of notebooks that is just, I think, worth checking out, and I've kept an eye on this a bit, but they've been developing some new ones. I don't know if you've seen the Callisto project.
No.
So it's a
notebooks.
That might come up. I just dropped the link in the chat. There's like, then if you go to, hold on. Actually, that's where you want to go. They're learning modules. It's targeted at grades 5 to 12 education in Canada. And so there's just like a suite of sort of data science examples. And some of them are, if you go, Steve, up to the top 2 resources, learning modules. Yeah. There's just like there's some really creative notebooks in there. So it could be fun to just like take a look and sort of see what people have been up to. Because thinking about that like grades 5 to 12 audience, that it's a different, like they're trying to promote interactivity and sort of exploring data, teaching some computational concepts. But it's not sort of all about learning necessarily how to code. So there's just some cool ideas in there. There's one of the ones that I've seen, I saw a really nice talk on, I can share that too. If you take a look at the indigenous content that they have, there's a beautiful example or a set of notebooks on actually the patterns used in basket weaving in some of in an indigenous community on the West Coast in Canada. And it's up in resources again, Steve. I don't know why it's not listed there, but
okay.
And they go into like the geometry of the patterns. It's really cool. And so that's one that I think it's like a beautiful example of sort of like important cultural concepts, important culture, mathematics and computing, like all in one place.
Yeah, because there's a whole branch of mathematics just on repeating patterns, not on the fractals as such, but are there repeating patterns? There's more concerned about like how often they repeat and whether it can be repeated endlessly or not.
Yeah,
I remember that. Yeah, it's amazing. That's really nice, because I mean kids here are getting a lot of what to say, sort of sketch-based stuff with all this building blocks. So it's more learning how to code, but with blocks.
Okay.
So the problem about that, or the pity about it is, like a 9-year-old gets bored very quickly, because you're learning low-level programming concepts before you've learned interesting stuff that you might want to do.
Yeah.
With it, and this seems to be a bit the other way around, or it's nicely done. Cool. And is this is a notebook? Doesn't appear. Let me see if it will let me and still be happy.
I think you have to change, Steve, you have to change in the URL rather than at the end where it says Jupyter user notebooks. If you replace that with /lab, maybe.
Almost. Finding out. Oh, it is.
Oh, it was there. Yeah. Oh, it just didn't. Right. Now you should be able to find it. I don't know where the notebook is. Oh, yeah.
Yeah, I'm not sure which one we were on, but yeah, and now we can connect. Cool. Awesome. And opening Callisto, does that actually give you a computing environment, or is that taking you back to the website? Well, no, sorry. Ooh, forget I even said that. I'm in Jupyter. So of course, I've got a computing environment. Yeah. Awesome. That's great. Yeah. Sometimes I think maybe we should just, to make that a bit easier, to put the like lab or Curvenote or something, because sometimes does that. Again, that depends on the server.
I think part of it is because the way URLs are handled in the notebook versus lab are different. So the notebook, like The whole everything is in the path in the URL, whereas lab you're not now. Like now you're actually in a new app and it manages the path internally. So when you go to a notebook, you won't see it show up in the lab URL. Whereas if you're in the classic notebook, you do.
Yeah.
So it's a little subtle.
Yeah, but I've got a Curvenote to connect there by putting question mark, which is a search query. So most servers ignore anything after a question mark.
Yeah.
Or they'll parse it and only use what they need. And I put Curvenote, and now we've attached.
Oh, cool.
So that's a nice little trick. Because the Curvenote extension, we don't attach everywhere. We limit ourselves to where there's notebook, Curvenote, or lab somewhere in the title. Cool. That's awesome. Great. Well, should we leave it there? Nobody's got anything else to shout out about, and everything's working.
Where do I find your Curvenote on Altair? Is that under your username?
It is under my username.
Okay, perfect.
I will share it in the Meetups channel.
That would be great.
Altair is awesome. I'm just all excited today. I actually found this.
Thanks, Steve. That's really cool to see.
Welcome. Great. I'll see you. Well, there'll be another one next week. And maybe see you then.
Sounds good.
Cool.
See you guys.
Great. Bye-bye.